so this is 7.1 from our textbook, and we're done with operations of functions. Sum, difference, product, quotient. Really, you've done all those things, you just didn't do it in this context. Find the composition, that's going to be the new one, the one that's of significance to us, and we're going to find the composition of functions, a first function and a second function. You can see that there. If you're doing the sum and the difference and the product and the quotient, it's just stuff you've done before. It's just with polynomials. It's really what that is. So you can see here, you add two polynomials, you subtract two polynomials. You've done all that before. Multiplication is just distributive property. And then the division one. Of course, in this case, nothing will reduce or anything, but you could, in other cases, have that happen. And we've got this qualifier here because we know that x can't be 5. Because that would make that a negative 5 plus 5, and the denominator would be 0. So we know that's not possible. So if you're going to do the sum, this is the notation. You're going to do the sum of two functions. You have your f function and you have your g function. And so you can see what you do is you do this plus this. It would be really easy to do that. And so I'm just going to skip through. Subtraction, of course, we always say it's the negatives in your life that cause you the most trouble. So you've got your f of x function here minus your g of x function. Because of the subtraction in the parentheses, you have to distribute the negative, and that's how you would get that answer. But I want to get on over here to the composition. That's product. You can see the little dot there in the middle. So it's the multiplication of those two things. That's a trinomial times a binomial. So you're going to get 6 pieces. There may be some things that are like terms once you do that. You can see the 6 pieces here. It's just distributive property without FOIL because it's not 2 binomials. And you collect like terms. Division would be the same thing. If there's something that you could cancel, in this case there was not anything that would cancel, that won't factor in any way that will reduce with the x minus 4. So there's nothing you could do. But in other cases there would be something that you could do. So we're going to just jump right here into composition. The best way I can tell you how this works is when you do a function, you put in a number like x and you get out a value. You've done that for the last 3 or 4 years of your math career. You put in a value for an x, you get out a value. In a composition, you put in a function, or you put a value in a function, you get one out. You put that value in another function and you get one out. So it's the process of 2 things that you do. It'd be like going to the car wash and you put in a $5 bill and it gives you quarters. That's the first function. $5 bill in, the function of that machine is to give you quarters. Then you take those quarters and you put them in the car wash, or some of them in the car wash. That's the second function. So you take and put in the $5 bill, you get out quarters, you take quarters, put it in the second function, and you wash your car. And that's really what composition is. Now, we're doing it with algebra, polynomial situations. And you can see this notation here. You've got the little circle in the middle, but it's not filled in. Because remember a minute ago, when it was filled in, that was multiplication. This means composition. And so this says F composition G of X. Can also be written this way. Notice the orders of the letters, FGX, FGX, it's the same. I call this fog of X, just as a really easy way of relating that. And so, but you can see here in this model where you put in an X, you get out a value, you put that value in, and the other function, and you get out a value, and that's what the composition is. So, this was reminding us of some things that we could do. There's some things there that would be of value probably, but I want to get to this. So this says find fog and golf. That's what I call that one. Fog and golf. By the way, you could use different letters besides F and G. It's just those are very traditional. You could have H of X and whatever else, but those are very traditional notations for this particular concept. So here's how this is gonna work. And we're gonna get through this really, really quickly, so, you know, you can always go back and watch the video over. And so we're gonna do the fog first. So we're gonna do the fog of X, which is, as I said, order F of G of X. And notice how I sort of shifted the notation. I still FGX, FGX, but I put this bracket in, and what I remember from an order of operations is you always start in the parentheses. So I'm gonna start in here. So in here I have G of X. I have F of G of X, but I have G of X inside here. So I wanna look at that, and I wanna replace it. So what is G of X? Well, evidently, G of X is this. So I'm gonna do 2x minus 1. So here's what we're doing. I'm just gonna draw 2 lines here. I always do that, it's a habit I have. Because this frames what I'm doing. Now I'm going, oh, I'm gonna do f of 2x minus 1, not f of 3, not f of 7, not f of x, not f of 7x, but f of 2x minus 1. So I'm gonna be using the f function. Let me copy that down. Doing the f function, which is 3x minus 2. There's the f function. But I'm not doing the f function, not the f of x function. I'm doing f of 2x minus 1. See, this is the f of x function, but I'm not doing f of x, I'm doing f of 2x minus 1. In other words, everywhere I see an x, I'm going to replace it with 2x minus 1. So I'm going to have 3 times 2x minus 1 squared minus 2x minus 1. Notice I put the parentheses because I'm going to distribute the negative, and then the plus 4. So you can see here that I've got the 2x minus 1 everywhere I have an x here. So you can sort of see how that works. The details are all there. Now I've got some work to do, of course, because I've got to clean up this mess. So first thing I've got to do here is I've got to deal with this binomial squared. Now remember we said if you don't know the shortcut, then you got to do it the long way. So you would have to do 2x minus 1 times 2x minus 1 and use FOIL and collect like terms. If you don't know the shortcut, that's a 1. If you know the shortcut, then you know that it's just square the first term, which is 4x squared, twice their product, minus 4x, and the square of the last term, plus 1. I'm going to go ahead and distribute the negative here to the 2x and the minus 1, so I get the opposite signs, and then the plus 4. And so to finish this up, I would distribute the 3, which is 12x squared, minus 12x plus 3, minus the 2x, and I'm going to put those two together, make them 5. And then the last thing I have to do is collect these like terms. And so you can see, for example, that these two are alike, these two are alike, and so I could put them together. That's composition. That's the fog composition. Remember, they asked us to do both fog and GOF. GOF is going to be the same thing, just in an opposite order. It's going to be a different answer. Most of the time it would be a different answer. So I'm going to clear that off. And I'm going to do the GOF. So GOF is G composition F of X, which is equal to G of F of X. So, So like we saw in the last one, in the last problem, we keep the order of the letters, G, F, X, G, F, X. It's just that now when I'm looking at order of operations, I want to do what's inside the parentheses first. And inside the parentheses is F of X. So I'm going to be doing G of this trinomial. And so once I realize that's what I'm doing, I put double marks or double lines just to separate what I was doing up there. Okay, now I know what I'm doing. I'm doing G of that. So I'm going to get the G function, which is this. G of x is 2x minus 1, but I'm not doing g of x, I'm doing g of that trinomial. So everywhere I see an x, I'm going to put in this trinomial. Oops, x plus 4. So everywhere I see an x here, every time I see an x, I'm putting in that. See an x, I'm putting in that. So it's 3x squared minus x plus 4. This one's actually easier than the last one because there's no square to do, there's no negative to distribute, none of those things to keep up with. I'm literally just going to distribute a positive 2, so that's 6x squared minus 2x and plus 4, or plus 8 minus 1. I'm done.